angle A is always R1 plus R2. So RS is called emergent ray. Angle of deviation will first decrease and again increase when light is incident on the base. Don't get confused. Small d is angle of total deviation. Hello students, SD sir again from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. Thought for the day: salute your duty and you need not salute anyone. Pollute your duty, then you have to salute everyone. Importance of commitment and sincerity. Dear students, in my today's session, we will derive a very important expression, that is refractive index of a prism in terms of the angle of the prism and something called angle of minimum deviation. And therefore, we will also understand the concepts of dispersion of light. So the first concept or the first bookwork I begin here is to derive an expression for the refractive index of a prism. Very much asked 5-mark question in the examination. To derive an expression for the refractive index of a prism. Very much I understand in your lower classes, when you are taken to the lab, all of you have seen a prism. What is a prism? It is an optical medium. A prism is an optical medium which is made of glass. Light can pass through prism, alva. Glass allows light to pass through it. Therefore, I call it to be an optical medium. So the basic definition of prism says that it is an optical medium. It is made of glass. Now, I consider A, B, C to be the principal section of the prism. Keyword: principal section. A, B, C represents the principal section of the prism. Yenidu principal section andre? When you hold the prism, the part of the prism facing you is called principal section. In very simple words, the part of the prism that you can see, the part of the prism facing towards you is called as the principal section. Now, this BC is called base of the prism. Very important, note this. BC is called the base of the prism. I call the base as the normal. For a plane surface, we had a normal. Similarly, for a prism, we have a base, indicating that when light is incident on the base, no refraction happens. Please note, when a ray of light is incident on the base, no bending of light. The so-called refraction of light is not possible as when light was incident on the normal. So A, B, C is the principal section of the prism. B, C is the base of the prism where refraction doesn't happen. Now, AB and AC are the two refracting faces. We say AB is the first refracting phase and AC is the second refracting phase. Meaning to say, when light falls on these phases, there is refraction. Refraction cannot happen through the base. But when light is incident on AB or AC, the so-called refracting phases, bending happens. That is why exclusively they are called refracting phases. And here A is called the refracting angle, or it is also called angle of the prism. What do we call A as? Refracting angle, or it is also called angle of the prism. Now follow carefully. A ray of light PQ is incident on the face AB. So PQ is the incident ray. It is traveling from rarer medium and falling on one face of the prism. Now AB is a refracting surface. Light has to be refracted. It is refracted along QR. So QR is the refracted ray. And now follow the refracted ray QR comes out along RS. So RS is called emergent ray. Emergent andreno, something which comes out. PQ is the incident ray. QR is the refracted ray. And RS is the emergent ray. What is I1? Angle of incidence. R1, angle of refraction for the first surface. R2, angle of incidence for the face AC. And RS, angle of emergence. And that is what we have described very clearly in this description. Now, observe the diagram carefully. This angle of incidence I1 is composed of R1 and D1, where D is called angle of deviation. I1, which is the angle of incidence at the face AB, is composed of R1, which is the angle of refraction, and D1, which is the angle of deviation. Therefore, we can write I1 is equal to D1 plus R1. Follow carefully. I1 is composed of D1 and R1. So I write D1 is I1 minus R1. I am expressing refractive index of the prism in terms of angle of deviation. So D1 equals I1 minus R1. Similarly, I2 is composed of D2 and R2. I2 is composed of D2 and R2. Therefore, I write I2 is D2 plus R2, or D2 is I2 minus R2. So, the initial step, I have calculated what is D1 and D2. So, D1 is I1 minus R1. D2 is I2 minus R2. Now, if I observe here, the angle of total deviation, I want the angle of total deviation. Small d is the angle of total deviation, and it is given by D1 plus D2. Please keep in mind, small d represents angle of total deviation. So small d equals D1 plus D2. Substituting for D1, I1 minus R1 plus I2 minus R2. So, D equals I1 minus R1 plus I2 minus R2, or D equals I1 plus I2 minus R1 plus R2. So the question is, what is R1 plus R2? For that, going back to the diagram, observe carefully. I want all of you to observe. There is a cyclic quadrilateral. ಏನು ಕರಿತೀವಿ? Cyclic quadrilateral. A, Q, N, R. So we have a cyclic quadrilateral A, Q, N, R. And a theorem states opposite angles, the sum of opposite angles of a cyclic quadrilateral is supplementary, which means to say angle A plus angle QNR is equal to 180 degrees. Beautiful. Equation 1. So very clearly the theorem says for any cyclic quadrilateral, the sum of the opposite angles, they are always supplementary. So angle A plus angle QNR, they have to be supplementary, which is 180 degrees. And from triangle QNR, sum of three sides of a triangle is 180 degrees. So if I compare equations 1 and 2, cancels, 180 cancels. Very, very important. Take note of this expression. While working out problems, we require this. Angle A is always R1 plus R2. Angle of the prism, the so-called refracting angle, is always R1 plus R2. So, substituting here, R1 plus R2 is A. So, a very important expression, A plus D is equal to I1 plus I2. I have calculated the total angle of deviation and expressed equation 4 as A plus D equals I1 plus I2. Now, observe the graph. Very important. You will be doing an experiment on this. X-axis, angle of incidence. Y-axis, angle of deviation. If you observe, as the angle of incidence increases, I repeat, as the angle of incidence increases, angle of deviation will first decrease and again increase parabolically. As the angle of incidence increases, very clearly, angle of deviation will first decrease and then again increase parabolically. My dear students, here capital D is called angle of minimum deviation. Don't get confused. Small d is angle of total deviation. Capital D is angle of minimum deviation. So, from this graph, it is very clear. Here, small d is equal to capital D if I1 equals I2 is equal to I. Capital D becomes equal to small d when I1 equals I2 should be equal to I, which also means R1 equals R2 is equal to R. Therefore, here small d is equal to capital D. As I told, if I1 equals I2 equals I and R1 equals R2 equals R. So, what does equation 4 become? Or equation 3 becomes? Equation 3 was written as A plus R1 R2. Now, both of them equals R. So, R equals A divided by 2. And equation 4 reduces to I equals A plus D by 2. Now, very clearly, Snell's law says N equals sin I by sin R. I is A plus D by 2. R is A by 2. And this expression is called the prism formula, or it is the refractive index of the prism in terms of angle of the prism and angle of minimum deviation. A very important expression which we also use to work out problems. Next one, again, dispersion of light, but this topic is deleted from your syllabus. Now, I consider white light. White light, which is composite light, is a composition of 7 different colors. When this white light passes through a prism, what is called dispersive medium, it is split into all 7 colors. You can see Vidhyaashram, violet, indigo, blue, green, yellow, orange, red. That means white light or composite light is dispersing, is getting separated into its constituent colors when passed through a suitable dispersive medium. And this phenomenon is called dispersion of light. Here, what is important is not simply light passing through a prism. It has to be a white light, composite light, which is composition of 7 different colors. When it passes through a prism, it gets separated to its constituent colors. That is what is called dispersion of light. Now, no dispersion takes place in vacuum. When white light travels through vacuum or free space, the phenomenon of dispersion cannot be witnessed. Why? In vacuum, all colors travel with the same speed. Light has same speed in vacuum, so dispersion is not possible. When white light passes through a prism, most deviated color is red and is violet, and red is the least deviated color. Whenever dispersion happens, violet is the most deviated, highest deviation for violet and least deviation for red. Thin prism, a prism whose refracting angle is very small. How small? Less than 10 degrees is called a thin prism. A small concept called angular dispersion. Again, we will take this as an assignment. This is again rooted out from your syllabus, but refer your book. Certainly you will find interesting. So students, today we have completed a very important derivation, which is the prism formula. The next session, I come back with refraction through a spherical surface, concept of lens, lens maker's formula, and so on. Until then, have a nice time. Thank you.